Question number 16 says, for the equation, find three ordered pair solutions by completing the table, then use any two of the ordered pairs to graph the equation. All right, so the first part of this question, where we've been given an equation and then an ordered table of values, x comma y, we've done this several times now in this practice test, so that's not new. What is new is really the second part, right? Once we've got our xy table completed, we then have to use any two of these points to actually graph the line, and we'll be looking at how to do that. So first things first, let's complete our table of values here. So we are going to be using the equation x minus y is equal to 5. And again, here is a series of ordered pairs where either the x is missing or the y is missing, and it's going to be our job to find those corresponding missing values. So let's start with row 1, which corresponds to the first point on our graph. In this case, we were given a value for y, so let's plug that in. And as is our custom, we'll let this teal color be representative of the x, and this pink be representative of the y. So because we were given a value for y, we're going to plug that value into the equation and solve for x. So we have x minus y, but again, because we were given a value for y of 0, let's plug that in, is equal to 5. When we clean up the left-hand side here by distributing, we're going to have a negative 1 times 0, which is just 0, so that all goes away, doesn't it? And the only thing we're left with here on the left is x equals, and here on the right, positive 5. So that wasn't too bad. Let's go ahead and plug that value into our table, so positive 5, and look at our second row. So our second row, again, we have been given, in this case, an x value for the x coordinate of 3, no y value, so it's going to be our job to find that missing y using the given equation. So x minus y, but in this case, x has been given to us as positive 3 minus y is equal to 5. So let's isolate this y. Let's solve for y. Well, as we've seen many times now in this practice test, the coefficient in front of that set of parentheses is a positive 1. So when we distribute, positive 1 times positive 3 is still positive 3 minus y is equal to 5. And to get this y all by itself, just two steps here. First things first, we can go ahead and subtract 3 from both sides. We want to start isolating that y. Well, 3 minus 3 on the left is gone. The only thing we have remaining is a negative y is equal to, and on the right here, 5 minus 3 is positive 2. And we want y all by itself, and we want it to be positive. So we don't want negative y equals 2. We want to flip the sign of that y. And to do that, we can either multiply both sides by negative 1 or divide both sides by negative 1. I think in this case, I'll just multiply everything by negative 1. So negative 1 times negative y gives us a positive y, and negative 1 times 2 is equal to, well, negative 2. So there we have our value for the missing y. Let's plug that in. So when x is 3, the corresponding y is negative 2. And last, oops, deleted everything there. That's all right. Last but not least, we are solving for the missing x, so again, our equation is x minus y is equal to 5, and we have been given the y coordinate, negative 1, so let's find that missing x. So x and y. All right, there we go. So let's take our equation, x minus y, but in this case, y is going to be negative 1, plug that in, is equal to 5. And cleaning up the left-hand side here, when we distribute this negative, we have a negative times a negative gives us a positive. So we have x plus 1 is equal to 5. And last step to isolate that variable is subtract 1 from both sides. And that leaves us with x, because positive 1 minus 1 is gone, is equal to, and positive 5 minus 1, positive 4. So there's the last part that we need for our table. So let's plug this value in. positive 4. All right, so we've got our table all complete. So I'm going to go ahead and actually clear this screen and take a look. How do we actually graph this information? So remember, we've got 3 ordered pairs here, but the directions tell us to use any 2 of these ordered pairs to graph. So to graph this line, what we're going to do is we're going to click on this button here below the table, which says click to enlarge the graph. So here's our enlarged graph, and we're going to use all of the tools here on the right. Well, we're not going to use them all. We're going to use some of these tools on the right to actually graph our line. So choose any 2 of these points to work with. I'm going to choose the first point, this x comma y, this 5 comma 0, to plot. So to plot an actual point, what you have to do is select the line tool from the right, and notice that once I start to hover my cursor over the graph here, notice in the upper right hand corner here that this ordered pair is going to change as I move my cursor around the graph. So the ordered pair in the upper right there moves based on where my graph is or where my cursor rather is hovering. So I want to plot the point 5 comma 0. So I know that we always start right in the middle at the origin, 0 comma 0, and you can see that's reflected in the yellow box there in the upper right of that yellow box, 0 0. So positive 5 comma 0. Well, that means I'm going to move to the right 5 units. So 3, 4, 5. And notice that 5 comma 0 is in the upper right of that light yellow box there, which is exactly the point that I'm looking to plot. So if I want to actually plot the point on the graph, what I'm going to do is left click right where my cursor is, and that is going to drop a point on the graph. And now notice if I move my mouse around that I have a line that's starting to form on the graph. But the line isn't locked in yet. The line is waiting for me to click on the second ordered pair, and that is going to lock in our line. So we can go back over here and say, well, do we want to plot 3 negative 2 or 4 negative 1? It does not matter which you choose. You're going to get the exact same line. I think I'll just plot 3 negative 2. So again, we always start right in the middle, but I'm not clicking on anything. I'm not going to click my cursor, the left button on my mouse, until I'm ready to plot that second point. So let's see, 3 negative 2. Well, that 3 in our x tells me to move to the right 3 units, and the negative 2 tells me to move down 2 units. So 1, 2, and you can see that in that yellow box in the upper right hand corner is the ordered pair 3 negative 2, which is exactly the second row that I'm looking to plot from my completed table of values. So now that I'm ready to plot the second point, 3 negative 2, now I'm going to left click on my mouse, and you can see that because we now have 2 points, the line is locked in. So the tool selection went back to cursor, and I've got my line locked in. So if you are unhappy with the line, maybe you accidentally clicked on the wrong place, you can clear the graph and start all over again. Or you can delete a point, whatever you need to do to make sure that this line is representative of the ordered pairs in your table. So to save this as your answer, go ahead and click Save at the bottom of this pop-up window. And you can see when we come back to the actual test page here that the line we just plotted on the graph is now locked in as our answer. And we can zoom in if we want to actually see and make sure that our points are correct. So this looks like the point 5, 0, which is exactly what we wanted. And here we have the point 3 negative 2, again exactly what we wanted. So I'm comfortable, I'm confident that this is the correct line, and I'm ready to move on. So there we have it, question 16. We solved and found all of our missing coordinates, and then we actually graphed the line using 2 of those ordered pair solutions.